Push that rock here with Simpson math. Let's use our ability to recognize translations to graph a quadratic function in standard form. So if by translations, what I mean is if I have, let me blow this up. If I have what's clearly going to be a quadratic because of the square here, that's a 2, then I know that this is a parabola, but it's been shifted to the left 3 and down 1. So I just take the parent parabola, move left 3 and down 1. So we want to be able to use that knowledge, but we want to be able to do it when we see the parabola in standard form, in the regular ax squared plus bx plus c. Now you'll notice, and you should be suspicious, that I have an a that's 1. So we have it in standard form, ax squared plus bx plus c. The a for this particular one is 1, b is 6 here, and c is 8. This, what I'm about to show you, is much easier if there's a 1 leading coefficient. So keep that in mind. It'll be a lot harder when we have some leading coefficient other than 1. Okay, but what we're going to do is we're going to try factoring this to a perfect square trinomial. Well, a perfect square trinomial has, when you add the same number to get this, which would be x plus 3 and x plus 3. So a positive 3 and a positive 3 added give me 6. But notice that 3 times 3 gives me 9, not 8. So if this trinomial does not factor to a binomial times itself. And so, in fact, it may not factor at all. I guess it would factor to 2 and 4. 2 times 4 would give me 8 and add to 6. So I'm not factoring it in the traditional sense. I'm trying to create a perfect square trinomial so that it factors to a binomial times itself so I can see the shift. Now, so what I'm going to do is, I should have written that in smoke. And that's kind of my goal. My goal is to kind of have x plus 3 times itself, so that I have x plus 3 squared. But I don't have that, so what I'm going to do, it's a nice little math trick. I'm going to rewrite 8 as with a 9 in it. So I have 3 times 3 gives me 9, 3 plus 3 gives me 6, and 3 times 3 gives me 9. So I want a 9 out here, so I'll give myself a 9, but to keep it in 8, I put a minus 1. So I rewrote this 8 as 9 minus 1. Now I'm going to factor just this trinomial, this part of it, and leave the minus 1 out there. So now it factors to x plus 3 times x plus 3, and it has the minus 1 out there. Notice this 3 and 3 will give me the 6, and 3 times 3 will give me the 9. So this part of it is that trinomial. So I have y equals x plus 3 squared minus 1. So I see the shift to the left 3, and I see the shift down 1, so I know what to do with the graph. So we're now going to graph y equals x squared plus 6x plus 8, which secretly can be rewritten as x plus 3 squared minus 1. Okay, so we're now going to graph it. Here's our parent function right here, but we're going to graph shift to the left 3 and down 1. So if I'm going to go to the left 3, these points are going to go to the left 3. 1, 2, 3 is the vertex, but also down 1. Whoops, didn't even mean to put it out there. Go to the left 3 and down 1. So the vertex is here. This point's going to go 1, 2, 3 and down 1, so it's going to end up there. This point's going to go 1, 2, 3 and down 1. Wow, I even found the x-intercepts. Okay, that's not always going to happen so cleanly. This point over here, can we see it? Yes. It's going to go 1, 2, 3 and down 1. This point's going to go 1, 2, 3 and down 1. And so I have the new parabola here. And this is my y equals x squared plus 6x plus 8 parabola. And we can see the x-intercepts at -4, -2, and the vertex at -3, -1. Can y'all see that? Yeah, y'all can see it. Math made simple. Simpson math.